we are freezing down cells that we expanded, and so we now have 8 dishes, and the very first thing you have to do is grab your cryo vial. These vials are specific to freeze down cells because they keep your cells safe at liquid nitrogen temperatures. So you label it with the cell name, your initials, the date, and then you count how many cells are in this vial. So DMSO, or dimethyl sulfoxide, is the special reagent that helps cells keep them alive at low temperatures. So it prevents crystal formation so that your cells survive. Okay, freezing media, the calculations right here, it's always 10% DMSO, 40% FBS, that's fetal bovine serum, and 50% of your base medium. So we're just using DMEM because that's a cheap one. We're making 20 mils total because we'll be freezing down 20 vials, and you need 1 mil per vial. So it's going to be 2 mils of DMSO, which is the protectant, 8 mils of FBS, which is their nutrients so that they could survive this harsh protocol, and 50% of the base media, so that's 10 mils. So we have our 15 mil conical tubes right here, already labeled and ready to go for when we collect the cells. Our cryo vials are already labeled, and then we have our reagents right here. We're going to go ahead and make all of our freezing media at once so that we're ready to go, because you need to work quickly once you resuspend your cells in your freezing media. And this is also an exergonic reaction. So it is going to release heat when you combine these reagents together. You want to make this first and let it sit, and then begin detaching your cells, because that way you're letting it cool down. If you put your cells in this while the heat is being released, you're going to kill all of your cells. Okay, so here are our dishes with the cells that are confluent. They're about 70 to 80% confluent. The very first thing you do is aspirate. So we carefully, aseptically use a Pasteur pipette, which is those glass ones, to go ahead and aspirate the media, and that is the spent media, from our cells. Then we're gonna go ahead and add PBS, which is phosphorus buffer saline, and it's going to kind of give the cells a shower, because cells are kind of like a fish in a tank. They pee and they poop in their water, and so cells are the same way. They secrete their metabolic waste, and so we want to go ahead and clean them up with some PBS first, and then we can proceed to detach the cells. Okay, so then here we're checking. It's been 5 minutes since the cells have been in TRIPLE, which detaches them, but you can see that these guys that are not moving, those cells are still attached, and we want to make sure. So I'm moving the plate around. So you want to, the ones that are floating by, those cells are already detached and they're perfect, but the rest of them haven't. So we're going to set a 2-minute timer, and we're going to give them 2 more minutes to detach. For each of these 100 millimeter dishes of cells, we had put 3 mils of TRIPLE, which is what detaches the cells from the dish. Now, we want to neutralize this so that it stops cleaving, because otherwise what could happen is the cells could get cleaved and then die. So we need to neutralize it. What we're going to use is DMEM to neutralize, which is that inexpensive media. So you're going to go ahead and grab one of the bigger pipetters, and then you're going to do 3 mils per each one of these. Okay, so what we froze down today were smooth muscle cells. They're human aortic smooth muscle cells. They were passage 5, and then I think we had 7 vials. For each vial, it's a 100 millimeter confluent dish. We also froze down pericyte cells, passage 9, and I think we had 5 vials. And then we had normal human lung fibroblasts, which are NHLFs, passage 8, and I think we also had 5. Once everything is balanced, we go ahead and close the centrifuge, make sure it snaps. Then we check, hold on, don't do that yet. We don't want to once you do this, it starts. So we want to make sure that it's at 500 about. So 510 is good. So then that's perfect. Go ahead and now it's starting. So we're going to set a 5-minute timer and then we'll come back and get our pellets. Okay, so once the cells come out of the light, there's definitely a pellet there. Those are all of our cells, and that's a really large pellet, and you can see it here. That's a huge pellet right there at the bottom. Okay, so now we're organizing the hood and we're making sure that everything is perfect. So he's opening all of the cells so that they're ready to go. Our media is also open. We went ahead and brought in a microcentrifuge tube holder so that we can go ahead and place our cryo vials on there so that they're ready to go. Okay, so now that all of our cryo vials are organized and they're all open, so we can just pick up the lid, we're going to go ahead and get started. So the very first thing you're going to do is get your Pasteur pipette. That's the glass Pasteur pipette, and we're going to start off. Okay, so we just took our Pasteur pipette. We're making sure it doesn't touch anything, and then you're going to go into your first cell tube. You're going to aspirate, and you can make the tube kind of go sideways so notice that he is making the cells almost go horizontal, so that the point is that we don't want that Pasteur pipette tip to ever even go close to the cells, because if it does, it has so much suction power that it can take up a whole pellet, and if it does, then we just lost all of our cells and we would have to start over. So that is perfect. Okay, this is the very last step now. All of our pellets are clean. They have been aspirated. We have our pellets by ourselves, so we can go ahead and resuspend them into freezing media. So we put 2 dishes in each 15 ml conical tube. So we're gonna resuspend each one of these in 2 mils of media, because when you freeze cells, you wanna place 1 mil per cryo vial. So go ahead and do that. So all of the vials are done. He's closing them really, really well, and then he's gonna go ahead putting them into the Mr. Frosty, and then now into the -80.